Okay? Now, as a sort of segue into this, right, I want you to think about logs first because we're a little more comfortable with logs. When you differentiate log of, and I'm thinking chain rule, log of a function of some kind. Log of a function. Okay? We know what the derivative is. It's f dash on f. Yes? Okay? So you guys are starting to get better at recognizing this guy, right, and integrating to end up here, right? So you're starting to see things like this, and you recognize, you're like, oh, f dash on f, so I'm going to end up with a log, okay? But I want you to think with me about what happens with the inverse trig functions, okay? For instance, if I differentiate sine inverse of a function, what would chain rule tell me? Okay. Well, I'm going to get, I have to do the inside, right? So I'll get f dash. Okay. And then the rest of it is 1 over, so I'm just going to put a big fraction. Okay. What's on the denominator? Square root. 1 minus a function squared. Okay, now, this is hard. This is very hard. These are quite easy to recognize after some time, right? But when you square, and then you do this subtraction, right? It's hard to see where's the f that results in this f dash because it's been mucked around with quite a bit, okay? So what will happen is you will get very simple examples, okay? Or they'll provide you the substitution, okay? And they'll say, use this substitution to integrate this. Now I'm going to show you both, okay? So here's my first example. Where did I write it? Yeah, okay. Before I do that, we should do the chain rule for tan inverse. Okay, so it's going to be almost identical, right? Except we're going to lose the square root and we'll lose the minus sign. Okay, so easy example to start with. Let's go integrate x on 1 plus x to the 4. Yeah, that's what I said. Good. Okay. Now, you look at this, and if we didn't know inverse trig, we would say, okay, well, it doesn't match f dash on f, does it? And then you sort of scratch your head, don't you? But we sort of recognize it's going to fit under one of these. There's no square root, so it's probably not going to be sine inverse. It quite comfortably fits under this tan inverse kind of idea, right? So to make sure we don't screw it up, I'm going to do the full substitution. Okay, I'm going to say let u equal. Now, if you feel comfortable doing it in your head, that's great. It'll be quicker, okay? But I think your likelihood of mixing up like constants or getting your derivative of your f wrong, I think it's a significant risk to take. So I don't do it. Okay. What should I choose? I've got 1 plus x to the 4 on the denominator, right? So what would be an appropriate choice for f? Looks like it'd be x squared, right? If I stick an x squared there, I'll get 1 plus x squared squared. That's what I want, right? So I'll let u equal that, okay? That gives me a result for the derivative, du. Okay, and now I've got all my pieces, don't I? Okay, I've got a single x dx here, x dx. I kind of want 2 of them, right? So therefore, what I've got is actually half the size of what I'm after, right? Then I've replaced that x dx with a du, okay? And I chose u specifically so that I would have 1 plus u squared there. Perfect, okay? So this is a half tan inverse of u plus my constant. And then you just get rid of your u's again. Okay, good. Now, that was a fairly easy example, so they won't provide you a substitution to use on that because I think you can see it there, right? Let me give you another one, but it's a bit trickier. I think it's about the limit of what they would expect you to recognize without providing you a substitution. So have a try with this one. Yeah, I'll make it easy for you. Stare at it with me for a little while. Okay. Now, part of the problem is, like, we're expecting an f dash on the top and some kind of something squared on the bottom, aren't we? And that gives us 2 problems because number one, you know, we don't have much of a function on the top, And down here, I don't have anything squared. Or do I? Now that square root's a bit of a signal to you, isn't it? Right? Where might that square root come in? I need to have something squared in order to use this result, don't I? Okay? Would you like some time to think about yourself before I spoil it? No, just spoil me. My brain, for this time of day, my brain hurts. Okay, alright. Here's what I'm going to do. I need something on the numerator, right? Something on the numerator to match this. So I have a choice. I can put either of these on the numerator, right as a fraction, right? Which would be more likely as a candidate? Which one's more likely to be f dash, and which one is more likely to be f squared? Well, you can just think in terms of degree, can't you? Okay, this is degree half, this is degree 1. So I think the one with the lesser degree is likely to be up the top. So I'm going to write it as 1 over 2 root x. Okay, now it's on the numerator, it's a fraction. Are you okay with that? Now, I need something squared on the bottom. Something squared. Well, I have x there. X is the square root of x squared. Is it not? I need something squared, so that looks like the best option. This looks like it'll work for me. Does this fit? If this is f, is this f dash? And the answer is yes, because this is x to the half, right? If we were to differentiate, you would get a half x to the power of negative a half. That works, okay? Hard to see though, isn't it? Okay, it's much harder than with just logs. But now I'm in the right position. There's my f dash, there's my f. I can actually just go straight to the next line. That's tan inverse of f plus my constant. Okay. Of course, if you're struggling to see that a little more and go there directly, you can do the substitution. You can say let u equal the square root of x, so therefore du on dx equals 1 on 2 root x, and then go from there. Okay. But you can see it now.